Hey, fourth graders, welcome back to day 9 of October's Number Corner. Today is October 13th, and we have a couple of things on our agenda. We're going to update our calendar grid like we normally do. We will update our Race to the Millions, and today it's your turn. Hopefully you remember those rules we talked about or those strategies we talked about to help you play the game so that you can win. And then we will do a problem string. So buckle your seatbelts, get ready. I just want you to remember one thing. I need you to participate. This month, coming soon, you guys are going to have a test. And so if you're struggling with some of the ideas that we've been going through together, make sure you reach out to your teacher and ask for help, because I want to make sure that you understand everything that we are doing together for Number Corner so that you have the opportunity to do well on your test. So here we go. Let's start out by looking at our calendar grid behind me. So like I said, it's October 13th, so let's see what it looks like. Yeah, almost like the 7th, but now we have 2 of those things filled in. So I wonder then, how might I, or what names might I have for this calendar marker? Let's go to our calendar collector sheet. Okay, do y'all remember what we talked about, what this looks like or what this is? Good. So each one of these represents a tenth of the whole shape. So if I have 4 of them colored in, that is 4/10. You got it. I also showed you guys the other day what it looks like if I were to take lines and separate this into 5 groups. So if that's the case, I have 4/10, which is equivalent or the same as saying that I have 2/5. Okay, so then let's think about how that's related to money. Yeah, it's like having 40 cents. Very good. So I'm going to write being 40 cents because each small square could be worth 10 cents. All right, well then how do I write that as a decimal? Good, 4/10. 0.4. You got it. Let's go up here because it looks like I didn't fill this in. So I'm going to add that 40 hundredths or 4/10, much like we did today. So it seems like we have a little bit of a pattern going on. We have 10 cent and then 10 and then a tenth, which is like 10 cents because it's like having 1 dime. Then we have 20 cent, then we have 20, and then we have a fifth, which is kind of like having 20 cents because if I were to take $1 and share it between 5 people, each person would get 20 cents. 20, 40, 60, 80, 100, which is $1. So 10, 10, 10, 20, 20, 20. And then we had 25, 25, 25. Now we have 40, 40, 40. So wonder what's going to come next. All right, next we're going to go ahead and update our Race to the Millions. So here we are, and it's your spin. So let's do it. No way. You guys got the largest number on our spinner. So where might you put that? Remember what we talked about? Yeah, we're racing to the millions. So I probably want to put that digit in the, you got it, 100,000s place. Oh my goodness. I cannot believe this. So now we've used up one of our 100,000s place, and we're going to add that to our record here. So we got 900,000. Wow. And we're adding 900,000 to 44,010, which is going to give us, good, 944,010. You got it. So I wonder if Miss Trammell can catch up. We'll see tomorrow. All right, so now on to the main focus of today, which is a problem string. All right, so I just have a blank whiteboard that I'm going to use to draw out or illustrate this problem string that we're going to go through together. You guys have your Number Corner journal, and in the back of it, remember we have those pages that you can use for our problem strings. Okay, so today we're going to use that special thing that we used the last time. Do y'all remember what it was called? Yeah, it was a ratio table. We're going to use a ratio table, and that ratio table is just really going to help us show our thinking, and it's going to help us identify some strategies from some of the earlier problems, which usually are the easier problems, so that we can use those problems to help us solve the later problems, which will get more difficult as we go through our problem string. So here's the context for this problem string. My neighbor has chickens. Really. I've actually seen some people with chickens running around their backyard. So they have chickens, and those chickens have been laying a lot of eggs. And so she's been collecting them and putting them into egg cartons. Each egg carton holds 12 eggs. So in your own words, just go ahead and repeat that back to me. Right. Person has chickens. They're putting, and the chicken has eggs, and now we're putting them into egg cartons. But we need to know that each carton holds 12 eggs. Okay? Are we good with that? All right. So let's look through the problems. Let's start with the very first one, which is here. All right. So the first one says that my neighbor has 3 full cartons. So how many eggs does she have? So if I have 3 full cartons and I said I want to use a ratio table, how might I draw that out? I'm going to tell you that I'm going to create a horizontal ratio table. And so it might look something like this. I'm going to start all the way at the end. I'm just going to make a long line so we can keep track. And you guys may want to make your line in your notebook so you can follow along with me. And maybe I'll start it here. Okay, the first thing that we need to have on our ratio table is labels, okay? So what are we talking about here? Good, we're talking about cartons. And we're talking about how many eggs are going to be in each carton. So I'm going to put cartons here. And then we have eggs per carton. Or I can just put, I'm going to abbreviate number of eggs. Make that bigger. Maybe a little bit smaller. All right, so make sure you're filling yours in just like I'm filling mine in, okay? All right, so we have cartons, we have numbers of eggs. First question says she has 3 cartons, so how many eggs are there? And you may remember from last time that it's always good to start off our ratio table by labeling what 1 would look like. So if I have 1 carton, how many eggs do I have? You got it. There are 12 eggs in a carton. So I have 1 carton with 12 eggs. Now I can use that to help me figure out what would be in 3 cartons. Or maybe I could use my knowledge of 3 times 12 because essentially that is what we are doing. So I'm going to do that. All right, so somebody tell me what's 3 times 12? You got it, 36. So in 3 cartons, there are 36 eggs. All right, let's look at the next problem. Now my neighbor has 6 cartons. How many eggs does she have now? what could we do? Yeah, you could, or maybe you know your multiplication tables of 12, so you probably know 6 times 12. But what could we do if we're using our knowledge of what's already here on our ratio table? Yeah, I'm doubling the amount of cartons. So if I double the amount of cartons, then what does that do to my product, which in this case is the amount of eggs that I have? Right, that means I'm doubling the amount of eggs. So let me go ahead and add my line here. And now I have 6. And so if I double that, and here's really what's happening. Let me draw my arrows here. I am multiplying by 2. Y'all see that? Yeah. So I'm doubling the top number, which means I got to double the product. If I double one factor, I have to double the product. And here's what that would look like. 36 times 2, and we know that our times 2s is that number doubled, right? Right. Put that here, and 36 doubled is, right, 72. Good job. I'm going to add that here. All right, let's keep going. Now she has 7 full cartons. So how many cartons does she have now? That's 7 times 12. So I know that I need to add 7 here. But how can I use what I know or what's already on my ratio table to help me figure out 7 times 12? What can I do? Yeah, I'm adding one more group of 12. So here's what that looks like. In order to go from 6 to 7 cartons, 6 cartons to 7 cartons, I am adding 1. I'm adding 1, okay? But we got to unitize, so what does that 1 really mean? When I'm talking about 1, I'm talking about 1 carton. I added 1 carton, but how many eggs are in each carton? Right, there are 12 eggs in each carton, which means if I'm adding 1 carton, I'm really adding 12 eggs. So what is 72 plus 12? Good. 84 eggs. You got it. I also want to just show you really briefly or really quickly what it looks like to use the distributive property to solve 7 times 12, knowing 6 times 12. So just go with me here for a second. Okay, so 7 times 12 is the same thing as saying 6 plus 1 times 12. Okay, and so I'm going to pull that down here. And so if I'm distributing, that means this is what it looks like. 7 times 12 is the same thing as saying 6 times 12 plus 1 times 12, which is what we just did. So we know 6 times 12 already because we filled it out on our ratio table, which was 72. And we know 1 times 12. So here's what it then looks like. 7 times 12 equals 72 plus 1 times 12 is 12. And then we can solve for 72 plus 12, which is, you got it, 84. So 7 times 12 equals 84. All right, y'all with me? Good, let's keep going. Now she has 12 cartons. I know you guys know 12 times 12. I know you know 12 times 12. What is 12 times 12? Yes, it is 144, but I'm going to ask, how can I use the ratio table to help me? Just in case I forget, or maybe I don't know, or maybe I'm not sure. What is 12? How would we get 12 using one of these number combinations from here? Yeah, it's doubling 6. It's doubling 6. And we already know 12 times 12 is 144. So I'm going to go ahead and put that here. But we know that because we're doubling 6. I'm going to draw a bigger arrow here. We just doubled 6. Do y'all see that? Which means I have to double my 72. Because if I'm doubling 6 cartons and there are 12 eggs in each carton, then that means I have to double the amount that I have. And it's not letting me. So maybe I'll just have to use my pen, which is okay. So this was times 2. And this was also times 2. Good? You got it? All right. Well, now I want to know, I almost told it to you. The next one is 11 times 12. Now I have 11 full cartons. What can I do? Yeah, earlier we added a carton with 6 to 7. Right now, what are we actually doing? We are essentially taking a carton away, right? Because now I have 11 cartons. And I'm going to have to write these in because it's telling me I have too many things on my whiteboard, but we'll make it work. So I have 11 here. Okay, so if I'm taking away a carton, so instead of having 12, I am essentially subtracting a carton. And we know one carton has 12, so I need to subtract 12 from my total number of eggs, which would give me 144 minus 12, minus 10 is 134, minus 2 more is 132. Now I have 132 eggs. All right. Well, I think there's another problem. So let's see what it is. 10 full cartons. Yeah. Now we have 10 full cartons. Now I know you guys know your 10s. I know that you know your 10s. But it's okay when you know your 10s because those are things that we've been drilling inside of you. So we don't necessarily have to look for any relationship with our 10s because we know our 10s. So now we have 120 eggs, which again is taking away one group, which is taking away 12. So our very last problem, here it is. 13 times 12. I know we can solve it. Go ahead and see if you can figure out what you would do to solve 13 times 12. We want to use some already solved combinations here to help us solve other problems. Okay? So we doubled earlier. We doubled one factor, we doubled the other. We doubled the product. So now we're going from 13. What number might we want to use? Good, we probably want to use 12 because really, if we're going from 12 to 13, we are just adding one carton. And if we add one carton, how many eggs is that adding? We're adding 12 eggs. So 144 plus 12. Should be able to do that really quickly in your head. What are you going to get? Good. 156. Awesome job. Can anybody see another way that we could have gotten 13? Using what we already have here. Yeah, we could have combined our 10 times 12 plus our 3 times 12, which is going to give you 13 times 12. and we'd still end up with the very same answer. So make sure you have this completed in your number corner journal. We talked about relationships between on a horizontal ratio table this time with the numbers at the top and the numbers underneath. What's happening every time? Yeah, we are multiplying by 12 because there are 12 eggs in each carton. That means we kept the number that we multiplied by the same each time. 1 times 12, 3 times 12, 6 times 12, 7 times 12. I think the ratio table is very interesting. Okay, so I know that we have to figure out the part that's missing, but we have some things in our toolbox to help us figure that part out. So thank you for participating. Hopefully you have this all in your number corner journal. I'll see you guys tomorrow. Have a great day. Bye.